Good evening, everyone. I'm Imam. This is Rachel, Carlos, and Myeong. Our project is Crowdsensing the Census, heterogeneous best tool for estimating poverty. I'm sure everyone knows what is a census. It is simply enumeration of population, but what for is a census? One of the main purposes of census is to provide a detailed understanding of equity distribution of resources, which in turn could be used by policymakers like local municipalities, NGOs, and UN for social intervention like neighborhood improvement, public health and education service, and other social interventions. As a resource of social intervention is allocated based on population, equitably distributing the public fund and resources require population data, which is produced by census. The census data is also used to build poverty maps, which simultaneously highlight geographic variations and display different dimensions that lead to poverty. In conventional way, and it has become a common practice around the world, census is undertaken by the government every 10 years by enumerating individual manually or mail census form to household and door-to-door survey throughout country. This method definitely would cost money, time, effort, and resources that cause many developing countries cannot afford to conduct regularly and comprehensively. In addition, the census data to some extent is not able to address the challenge of the rapid economic, socioeconomic changes or demographic in the city due to urbanization because it is too infrequent, as I said, every 10 years. Therefore, we need an alternative methods and model as a new way to provide the low-cost, real-time, reliable data which is able to estimate the socioeconomic deprivation at the given area. This project attempts to develop a compositional method and model that automatically mine variety data source other than the census data and then looking for significant and strong signal of deprivation. We propose the alternative data source, a big data that might be used for estimating poverty. The method have a potential to offer a great value to organizations and agencies who currently struggle to identify the poorest part of countries due to the lack of reliable and updated data census in certain parts of the world. But how it works, Rachel will explain it.
So what we're interested in this project is answering the question of how can we leverage large, big data to kind of predict or be able to supplement census data that often becomes outdated with this quick urbanization in cities. So we have kind of, based on previous research, we have these two avenues. We have infrastructure sense data, we have transportation data like the ORCA team, we also have call detail records, that's something that we're very interested here. And we have urban crowdsourced data, so that's things like OpenStreetMap or social media data. So our question is, how can we use these two different avenues of data to be able to predict census level variables, specifically socioeconomic deprivation? So based on this previous work, it sets up a basis for our project objectives. We are able to kind of, this is kind of an avenue of interest in predicting poverty, and so previous work has used CDR data and OSM data and other sorts of open data to develop methods to predict poverty. We found from these previous research that CDR works better for developing countries. It also works better at the country level as opposed to the city level, whereas open data like OpenStreetMap can often work well for city level predictions. And we have this tension that we're dealing with in this previous research where CDR is not necessarily publicly available. So call detail records also often have privacy concerns, and they're collected by private corporations and telecom companies and stuff like that. And whereas open data is not necessarily even, often you'll have cities that might not have full coverage on OpenStreetMap, and so we have this kind of tension of which one is better when we're building a model to predict poverty. So our project objectives are to suggest a generalizable model for predicting socioeconomic levels in cities using call detail records and/or open data. And then our second objective is to kind of provide a visualization tool that people, NGOs, the UN, and our stakeholders can use to explore urban poverty data and predict deprivation. Sorry. Okay, so I'm just going to go through quickly our data that we have. We have 2 case studies. We're working with data from Milan and Mexico City. And we collected data from 3 different sources. We have census data as our ground truth, as our method for verifying our models. And then we have our call detail records and OpenStreetMap data. These are the 2 avenues of our project. So for Milano, we have census data at a census area level. So we have polygons, and there are 86 of them in the city. And then we have call detail records, and we have about 525 million records over 2 months in November and December of 2013. And then we have OpenStreetMap, which we extracted data from OpenStreetMap, and we have about 20,000 points of interest, and we have some street data. And then for Mexico City, we have about 5,731 administrative areas. Mexico City is much larger than Milano, and we have a much finer resolution for Mexico City. We don't have any call detail records, but we do have OSM data. So we're working with how we can build a model where we don't necessarily have the same kind of urban area. We don't have the same kind of urban fabrics, and we also don't have the same availability of data, because that's often the case. Okay, so in order to develop our ground truth for our census, for our model that we're developing, we have indices of deprivation, or poverty indices. For Milano, we have had to generate an index on our own, whereas Mexico City, the data that we collected from the National Institute of Statistics and Geography, they already had an index of deprivation developed for us using education, health, and dwelling quality and resource availability. For Milano, we developed it ourselves using, based on the UN standards, as well as previous research specifically for Italy on how indices of deprivation are developed for Italy. So we took into account high school education attainment, illiteracy rates, population age, foreign population, and the renter versus owner status and unemployment. So we'll just kind of take a look at what those kind of look like spatially. So on the left you have Milano, on the right you have Mexico City. You can see obviously these are very different cities, and these are not to scale, but you can tell that there's no scale bar, sorry. We can see that our census polygons are different sizes and resolutions. We have these larger polygons for Milano, and we have these smaller polygons for Mexico City, and we have 2 very different urban fabrics. And we're just looking at the spatial distribution of our indices of deprivation at the moment. And if you notice, when we're working with spatial data, this is just something we're keeping in mind when we're trying to predict a variable like poverty. It's geospatially correlated, so this is something that we're just keeping in mind when we're working with this data, that our data for different cities is going to be related to each other spatially, and space is a component in our model, because poverty in one polygon is related necessarily to the neighborhood around it. So we're looking at, for example, Milano, our spatial autocorrelation exists up to 4.5 kilometers of a certain neighborhood, and Mexico City 16 kilometers, because they're very different cities with different scales. Okay, so now on to our first avenue of research of data that we're working with. We have OpenStreetMap data, and in this case we are working with 2 different types of data from OpenStreetMap that we extracted. We have point of interest / urban amenity features, and these are in the form of points, as you can see on the right, left. Points of interest data, and we have public amenity features. These might be indicators that we're looking at based on previous research that have been used before to see the distribution of resources and accessibility in the urban spaces across our city. So in this case, we're just kind of visualizing some of the variables that we have, and we're taking into account that we extracted from OSM. And for our second kind of data set from OSM, we have the street network, and these are the form of lines that represent streets. And we can take from these, we're looking at the street centrality features as a potential indicator of the connectedness of a given neighborhood, so that we can estimate the spatial distribution of accessibility, again, in a different format for our streets. And these 2 visualizations were of Milano. And then our second avenue of data, we have our call detail records, and that's the data that we have just for Milano. It's publicly made available, and that was the 2013 data. And we have 2 different kind of sets from CDR. We have call amounts, that's just the amount of calls, internet, and SMS in and out that we have, and it's aggregated to a grid for across the city, and there are about 10,000 cells. And so we have the cell tower location. We don't have the cell tower location, we have it aggregated to a cell. And then we have this call network data, which relates to how a given neighborhood is interacting within the city, so we can see relative to the rest of the city how a certain neighborhood is connected. Cool. Okay, so now that we've kind of familiar with the data, we can talk about how we extracted features that would help us predict poverty from these two data sets. So in terms of the urban amenity features for OpenStreetMap, we have those points of interest. So we kind of extracted them based on the keys amenity and public transportation, because we're looking at these points of interest that might be urban features that would indicate a spatial distribution of accessibility. And we had to manually, because this is crowdsourced data, a lot of the tags are not necessarily, they might be misspelled or they might be very specific. So we aggregated them manually to these super categories that we could use. And then we wanted to not just use the density of points, but we wanted to capture amenities in a given neighborhood based on a specific category that occur more than the average neighborhood. So we calculated this offering advantage so that a given neighborhood has a certain offering advantage for a category compared to the rest of the city. So basically, when we were doing this, like I said, Mexico City doesn't have the same amount of, it has 6,000 points, although it's a much larger city, whereas Milano has 20,000 points of interest, and it's a smaller city. So when we were working with these two uneven data sets, we kind of figured out a methodology to deal with this uneven OpenStreetMap data. So for Milano, we had more data, but it was at a lower resolution, and we just aggregated the points of interest and calculated this offering advantage. Whereas for Mexico City, we had uneven data, and it was at a higher resolution, but it was incomplete. So we aggregated the points of interest, we calculated this offering advantage, and then we interpolated across because we had a lot of null values. We basically calculated the offering advantage values based on predicting or interpolating using inverse distance weighting, so that we could have values for an offering advantage for the entire city, even if the data was uneven. So we're just going to take a look at that. This is the offering advantage of bicycle offerings. Bicycle offerings is just a super category that we created from OSM tags for amenities like bicycle parking, for example. And we can see the spatial distribution of Milano's bicycle offering advantage. Whereas Mexico City, we have an offering advantage of bus stations, for example. These are just example categories. And you can see that they look kind of different because it's the interpolated values and for a higher resolution. And so we can just see how we have a spatial distribution of bus station offering advantages in Mexico City.
So let's consider now a couple of urban accessibility and connectedness measures. For need, we need to consider the street network. So we can represent it as a graph where the nodes are the street intersections and the edges are the streets themselves. We're particularly interested in global and local centrality measures because they are good indicators of the spatial, social, economic prosperity, accessibility features of a city. So our first measure is closeness centrality. It captures the global centrality of a network in general. This can mimic the spatial distribution of economic activity and accessibility. That can be a good indicator of spatial distribution of poverty. Here we can see the Mexico City centrality. It usually the center parts of the city have a high closest centrality. Now we have between centrality. This is more local indicator of centrality. It measures in which extent some streets connect neighborhoods together. So this can indicate how much access a certain neighborhood has to the rest of the city. Here we can see, like in red, the main avenues that have high between centrality.
Also, it is possible to extract the features from CDR data, which can provide poverty indicators. One very basic feature is core volume, and that represents transient number of people. It's different from like number of residents in each area. And the next one is network advantage based on the network data. The first one, there are features about popularity and importance of each region based on the communication network. And also there's a measure of diversity of each region in terms of communication network. And the last one is relative amount of interactions, which is termed introversion. So having these different kinds of features, we put CDR features and OSM features into regression model. And then also we took baseline features such as random variables and population density into account to see how much we can enhance the prediction power using these features. So talking about the results, first of all, this is the result of the city of Milano, and the features are based on OSM. As you can see, the offerings advantage based on bar predicts 14% of the poverty level, which is 7% enhancement from the population density, which is a baseline in the city. Also, it is possible to create features based on bar offering advantage, bicycle offering advantage, and street network features such as closeness and betweenness centrality. But the prediction power is not that great here. And also, CDR itself is not a great predictor in the city of Milano, because the city is different from developing countries. City is new place to predict poverty based on CDR, and here the prediction power is below baseline. But when you combine CDR with other OSM features, the prediction power goes up by 18%. So we can say CDR can complement OSM features in predicting the poverty. When you look at the city of Mexico City, the performance is way better because we have many more features and data there. Here, bicycle offering advantage and closeness centrality predicted 50% of the poverty, which is 48% enhancement from the baseline, from the population density-based measure. And also, other street network and closeness, betweenness, and offering advantages do better job than the baseline. But from the perspective of stakeholders, such as the UN or local government, they need to see how these different kinds of indicators work differently in different cities. So in order to tackle that issue, we built a visualization tool, which will be introduced by Carlos.
Now I'm going to turn the light off real quick.
So there's a URL in case you want to try it as well. Okay, so this is it. In the left hand, we have our ground truth data for deprivation. This is the city of Milan. Ideally, we would like to have here the predicted value, but for now it's the ground truth. In the right side, we have here is closeness centrality, but we can select from this menu any other predictors that we want to check. So let's see, for example, if we want to see the university offering advantage. So surprisingly, this is positively correlated with deprivation in Milan. So let's see what's going on here. This is a spot with the highest offering advantage for university. So as you can see here, because it's a university place, it has a lot of bars. These all these red dots. In fact, you can see in this visualization, I don't know if you can see, like this observation falls in this part of the distribution, and it also curiously, this observation falls in the like it's the most deprived place in Milano. I don't know if it has to do with students with low budget or probably unemployment rates as well. We also can select, for example, here, for now we can choose Mexico City. So for now we can only choose the option between two cities, but ideally we will have an option to import data sets and to select new cities. So it can be processed in our tool and have a predicted value in our tool. So for this, we need to generalize for a model to make this actually work in real life. So just to close, when we work with this kind of data, we have to be careful with some ethical concerns. A good model that predicts poverty accurately can have negative implications like discrimination and disinvestment. Thank you.
Some of the measures you guys use would be more mobile year by year, and some would be more static. Like the amount of bike parking, for instance, probably doesn't change a lot year by year, but the number of cars probably changes a lot. Is that, I mean, how does that figure into your like weighting, that kind of thing?
So we talked about it a lot, trying to bring in some sort of time component, but the issue that we're dealing with OpenStreetMap data is the timestamp for the data doesn't necessarily relate to when the bar was opened. It could just be when someone added it to the map. So I mean, we had a lot of discussions. It was something that we want to include, but it's like kind of hard to deal with when we're looking at OpenStreetMap data to determine what that timestamp actually means.
Gotcha.
Although changes to the map, like deletions, might be a good indicator of when something might close, for example.
Does the pure lack of data correlate with poverty at all? Like,
Yeah.
I'd imagine that places where people are, struggling to, I don't know, food, they wouldn't.
Yeah, actually,
People say there are a lot about OpenStreetMap data, but there's also a lot of initiatives in certain neighborhoods to get data on the map. So I mean, I wouldn't make a general statement about the lack of data, especially with OpenStreetMap data necessarily, but I mean, yes.
Is that like, I
Possibly.
Does that bias your analysis? That
Definitely, especially in like Mexico City, for example, you'll see that the center of the city has a lot more data, and so that was something that we were dealing with when we were looking at using OSM in Mexico City as just our case study.
and yeah, we have some variables that some offering advantages that doesn't relate at all, but they are highly correlated because of the lack of information. It capturing something somehow.
Thank you.
Welcome.
Did you try to predict anything other than poverty? I'm just curious what sort of accuracy measures you may have done if you did.
Our main project objective was.
Yeah, not yet. Yeah, we haven't tried it. Yes.
Curious if you looked at commute factors here, right? A certain area might have a whole bunch of amenities that is drawing from like nobody that lives in that area, and likewise even the people that own those shops might live across town. So
Definitely, and that's something that CDR data might be really helpful for, because we're looking at, for example, call volume might not necessarily indicate where people live, it might just indicate where activity, like economic activity. So I think that's something that we worked a lot with the CDR data in different ways and separating it out by time of day, different weekend, weekday, to kind of see what we can extract from the features and to be able to kind of tell that kind of movement within a city.
Do you have any comments on why in Milan you had lower prediction power?
I think the biggest thing is that there are only 86 points of data that makes the statistical power lower. So our next step is to analyze it based on the smallest block level data. But in order to do that, we need to clean up the data some more. So yeah, that will be our next step.
Is there, so you normalize the poverty levels between the cities. So is there any possibility that because you might have less poverty in some cities, it's more difficult to predict accurately that because you have less variance, so it's more difficult to predict.
Definitely, and one issue that we're dealing with, for example, is at one point we had developed an index of poverty that using all of Italy's data, and Milan is a very specific city because it's comparatively very wealthy, and so it's something that we were dealing with a lot because we have very specific case study in Milan.
Yes. Did you get a feeling for what kind of data you might want to use if you wanted to achieve the same granularity as a real census? So, actual like street, areas where I come from, you can move one street over and it's a completely different type of area, and then you move one street again and it's gone back to a higher level of deprivation or something. I mean, did you, just in talking about this, did you get a feeling of what you might have to use to get to that level?
Well, I think we definitely would want to look at the higher resolution polygons in the census, in Milano. I think the street centrality data was also very interesting for that kind of work. I think that, I don't know. I mean, we're also thinking about other social media data beyond just open source data. Like we said, there are two avenues. There's infrastructural data, but there's crowdsourced data. So there are other opportunities, like Airbnb data is something that might be interesting in an urban area. Other social media data, yeah. It's something that would be an interesting avenue of research.
I guess just to add to that, actually, predicting poverty level at the street level, I understand what you're saying, because actually where I also come from, like from street to street, it can be very different. But the tool and the efforts here is actually supposed to be a tool for municipalities so they can invest budget. So I don't believe that they would need such a fine granularity to invest budget in a specific street, but more like borough level or census region where they can actually allocate and allocate resources. So in this case, I guess one good thing about the tool is that even